Hi chemistry students, today we're going to look at the shorthand electron configuration. We're also going to review some of the energy level diagrams that we talked about through our activity in the auditorium. So let's review energy level diagrams first. On the note sheet that was given to you in the auditorium, we talked about energy level diagrams, and basically an energy level diagram shows a full visualization of the arrangement of electrons among orbitals within an atom. Each line represents an orbital which can each hold 2 electrons, and those lines that are at the bottom of this diagram are going to be lower in energy. So for instance, if you are looking at the 11 electrons that are located in sodium, we would first be able to show them by drawing arrows just like this, going from lowest to highest. And so it's 11 electrons would be shown just like this. Now, you can see here that the 1s orbital is the lowest in energy because energy is increasing as you go up. You also can see that there's only 1 electron that's in the 3rd energy level. This 3 represents energy level, 3rd energy level, and in the s orbital. It also shows all of the arrangements of all of the electrons, so it's a full visualization of all of the electrons in their orbitals and also where they are in respect to energy. There were 3 rules that we needed to remember when we were trying to draw our energy level diagram. These 3 rules dictate where the electrons are going to be placed in the energy level diagram and how they are arranged. The first rule is the Aufbau principle. You do need to know the name of the actual rule. So this is the Aufbau principle. And it states that electrons fill the lowest energy orbitals first. So if we go back, you'll notice that I put the first electrons in the 1s. That's because the 1s is the lowest energy orbital. Our next rule is called Hund's rule. It states that when we have an orbital with multiple orientations, so like the p that has 3, or the d that has 5, or the f that has 7, electrons are only going to fill up 1 at a time before they pair up. So I like to tell students, place 1 in each box before you double up. So going back to what we were looking at earlier, what you'll notice is when I get ready to put my electrons in the s, I put 1 in there to start with, and then I double up. Place the up arrow in first, and then I double up if I have enough electrons. So far, if we were looking at sodium with 11 electrons, I've placed 4. I still have 7 left. So when I get to the p, I place 1 electron in each of the lines, the orientations, and then I can come back and double up. Finally, my last electron goes in the 3s, and I only have 1 to place there, so I just put an up arrow to show that last 11th electron. The very last rule is the Pauli exclusion principle, which states that if 2 electrons occupy the same orbital, in our case with our energy level diagrams, it would be the line. So if they are both going on the same line, then they cannot have the same spin. They have to have opposite spins. So we show that by putting 1 with an up arrow and 1 with a down arrow. So before we get started, make sure that you pull out your periodic table that you were given at the beginning of the year, your large one, because you're going to need all of the space. Mine's blank. Yours actually has all of the symbols on it. And what we're going to do is we are going to do some labeling real quick. I'm going to show you a trick to use to help you with the electron configurations. So, on your periodic table, you have this labeled hydrogen, and this one is labeled as helium. For this little quick trick to work, we have to move helium's box over beside hydrogen. So I want you to draw a little false box over here beside hydrogen, and I want you to write a little HE over there, just a little tiny one, HE, so that you can know that this is the box I'm going to use for this trick. We're not going to use helium here. Don't cross it all the way out, but we're not going to use helium over here. Its box has now been moved over beside hydrogen. Now, we know that the s orbital can hold 2 electrons, correct? Notice how these 2 columns here only have 2 boxes. So right here I have 2 boxes going all the way down in these 2 columns. Those are going to be my s orbital electrons. So put an S over top of those 2 rows. Notice how there are 6 boxes going across on the other side. Those are going to be my p electrons. And then over here in the middle there are 10. There's my d orbital electrons. And finally at the bottom there are 14 boxes going across those bottom 2 rows. Those are going to be my f orbital electrons. You'll also notice that there are 7 rows. Do you remember what 7 means? Well, 1 through 7 are my energy levels. That's my first quantum number. So these are my energy levels. Now that we have this set up, I'm going to show you how to do I'm going to show you how to do a little quick trick to find the full electron configuration for various elements. So the question is, how can we use the periodic table that we just labeled to write electron configurations? What you're going to do is each time that you want to do an electron configuration, you're going to start with the hydrogen in the upper left. He's going to be in the first row, which is your first energy level, 1, and in the s orbital, which again is your lowest energy orbital, so we're going to fill that one up first. We're going to move across 1 row at a time from left to right. And we're going to be, again, writing down the row that we're on. That's the 1 for the first one, the s for the orbital, and then we're going to use the boxes to tell us how many electrons. Once you get to the end of the row, then you have to start at the next energy level. So if you go down to the second row, you're in the second energy level, then what area are you in? What orbital? You're in the s orbital if you're at the left side of your periodic table, so 2s. There are 2 boxes there, so that gives you 2 electrons to place there. And you're going to continue to keep doing this, going from left to right, until you reach the element that you are looking for. So our rules here state that we're going to start with hydrogen in the upper left, move 1 row at a time from left to right. When you get to the end of the row, you're going to move to the next. When are you going to stop? You're going to stop when you reach the element that you are asked for. And yes, you do have to count the box for that element as well. You have to count that one as an electron. So, sounds confusing, but it's really not. Let's look at our periodic table again that we labeled. So we've got our S up here, we have our P here, we have our D here, and our F is here. We also have moved helium's box over here beside S to make sure that we have 2 boxes for our S column all the way down. We're going to take our box here away, we crossed it out. And now we're ready to go. The first example that we want to work is potassium. So where is potassium on your periodic table? Well, potassium is here in the 4th row. Now, potassium has 19 electrons. How do I know? Because the top number, the atomic number, is 19, telling me that I have 19 protons, and because we're just going to be looking for potassium, I'll go ahead and write it at the bottom. Here's potassium. Since I'm looking at a neutral atom, I don't see a charge in this top right corner. Nothing's right here. So I don't have a negative or a positive. I just have potassium. So positive protons equal the negative electrons. 19 electrons. To do this, start at the first row. I'm at my 1s, and the boxes represent the number of electrons. So I'm going to have 1s2. That's the first thing I'm going to write. There are no more boxes because we moved helium. No more boxes there. So I'm going to go to the second row. I'm at the 2s. There are 2 boxes there, so I'm going to place a 2. I still have some boxes on the second row, so I'm going to write my 2 there. And now I'm over here at my p orbital. 2p. And there are 1, 2, 3, 4, 5, 6. There are 6 boxes. I'm still not at potassium, so I can't stop yet. I'm going to go to the third row, and that's 3s, 3s, and 2. There are 2 boxes. 1, 2. Still not at potassium, so I keep going. I'm still on the third row, third energy level. I'm over here at the p's. Let's write my p. And I have 6 boxes going across. 6 electrons. Still not finished. I have to go down to the fourth energy level, fourth row. I'm still at the S over here, still up here at the S. Now I'm going to write a 1 because I'm stopping at the first box because that's potassium. And I've just written my electron configuration for potassium. The next one that we want to try is sulfur, but this time we're going to look at sulfur with a -2 charge. Okay, so sulfur with a -2 charge. Well, I know on my periodic table that sulfur is in the third row, and it's over in the P column. It's going to be right here. And I know that sulfur is supposed to have 16 electrons because it has 16 protons. That's what my atomic number tells me. So 16 protons, 16 electrons, but wait a minute. I've got this -2 sitting right here. What does -2 mean? It means I have 2 more electrons. So I have 18 electrons I need to place. Well, if I have 18 electrons to place, am I going to stop at that box? No, because that is telling me that I have 16 electrons. I got to go 2 more boxes. So I'm actually going to stop 2 boxes to the right because I gained, or I have 2 more electrons than what my sulfur here in sulfur's box actually tells me. So now that I have my stopping point, let's get the electron configuration. So start at the beginning here. Always start at the first row. 1. I'm in the S's right here. 2, because I have 2 boxes. 2 boxes. Next, I'm going to go down to the second row. I'm in the S again. And I have 2 boxes here. 2s2. Next, I'm still on the second row because I've got these boxes here. So I have electrons that are still on the second energy level. So I'm going to write 2. Then I have p. I'm in the p orbital. And I have 1, 2, 3, 4, 5, 6. 6 electrons. Still not where I need to end up. I need to get over here to my end spot. So I'm going to go to the next row. 3. I'm at the S. and 2 boxes gives me 3s2. Still not where I need to end up, so last thing I write is 3p, and I'm going 1, 2, 3, 4, 5, 6 boxes over, so 6 electrons. And that's how you do an element with a charge, or what we call an ion. So what is the difference between the longhand electron configuration and the shorthand electron configuration that we're going to talk about today? So I've already shown you a shortcut to using the periodic table in order to get your electron configurations. So what's the difference between the longhand electron configuration and the shorthand electron configuration? Well, the longhand electron configuration for potassium that we just did was 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. When we get ready to do the shorthand electron configuration, what we're going to do is we're actually going to find a bookmark place. Well, what do you mean by bookmark? We're basically going to use an element as a bookmark. We're going to use that element to say that, okay, we're using everything before you, and then let's finish it off. So it's a place that you can start other than starting at hydrogen at the beginning of the periodic table. Let me show you. So every time that we've done an electron configuration in this lesson, we've always started at the beginning with hydrogen. So we always started over here at hydrogen. With the shorthand electron configuration, we're going to use these elements in the far right. We're going to call those noble gases, and we'll talk about why they're noble gases and what noble gases are later, but we're going to use this column that we call noble gases as our bookmark. So instead of us having to start all the way over here at hydrogen, we're actually going to be able to start with one of our noble gases and not have to write everything that's before that. So here's potassium. If you go up one row and go all the way over to the right, we can place argon in brackets, and that's our bookmark. That's our placeholder. It's telling us that potassium's electron configuration is exactly the same as argon, except what's the last thing that's different about potassium's electron configuration and argon's? Well, potassium has an electron in the 4s orbital right here. This last box for potassium is in the 4, it's in the s, and there's only one of them. So again, I went up one row and all the way over to the right. Argon looks exactly like potassium in its electron configuration, except for the last electron that potassium has, and that's in the 4s. So I write 4s1. So going back to what we were previously looking at, if my shorthand electron configuration looks like this, then what is the difference between the longhand electron configuration and the shorthand electron configuration? The longhand electron configuration that you've been writing shows every single one of the electrons. The shorthand electron configuration is only showing the electrons in the outer energy levels, or the electrons in the highest energy orbitals. And that would be the 4s1. Now, just to show you, if I were to write the electron configuration for argon, and you can try this, it would look just like that. Because argon has 18 electrons. 2, 4, plus 6 is 10, plus 2 more is 12, plus 6 more is 18. There's my 18 electrons for argon. Potassium has 19. There's my 1 for potassium. So putting all this in brackets as argon is saving us from having to write all of this first part of our electron configuration, and we're only having to finish up with the last section of the electron configuration, or the electrons that are in the highest energy orbital. So what are the rules for writing the shorthand electron configurations? We've gone through a lot today, so let's just backtrack and make sure that you understand the rules for writing the shorthand electron configuration. First, you want to place the noble gas that is one row above the element you are looking for in brackets. So find the element you're looking for, go up one row, and go all the way over to the right and put that in brackets. That's going to be your new starting point. Number 2, finish the electron configuration for the element from the noble gas in brackets. So once you have your new starting place, once you've put your noble gas in brackets, then you can start your electron configuration finishing off from that noble gas. The example that we just showed was potassium, which you can see here. Notice again that this is the electron configuration for argon, and by putting it in brackets, I have a new starting point. I'm basically saying that potassium's electron configuration is exactly the same as argon's, except for this last little part. So let's do the shorthand electron configuration for scandium. So the shorthand electron configuration for scandium, we would basically go up one row and go all the way over to the right, and that noble gas is going to be argon. So I'm going to take argon and put it in brackets. That's going to be my new starting point, and I'm going to finish off the electron configuration with 4s2. There are 2 boxes there. But now, wait a minute. Ms. Adcock, you didn't show us how to do the D's. What happens when we get to the D's? Do we just say 4D? Well, actually, no. Take your periodic table and I want you to label some numbers. I want you to write a 3. I want you to write a 4, 5, and 6. I want you to go over here and write 4, 5, and 6. When we get to the D's using this particular model using the periodic table, you have to jump down one energy level to pick up the D's. So I'm at the 4s. I'm going to go down one energy level, 3, and pick up my D's. So 3D1. So argon was my new starting point because I went up one row and all the way over to the right, so I didn't have to do all the stuff before. To finish my electron configuration for scandium, I have to write 4s2 because I have to finish the 4th row. But when I get to the D's, using your periodic table, the D's are always going to be one energy level lower than the S and the P's. So since 4s, I have to go down one energy level to 3D. Let's look at phosphorus. So here's phosphorus. Remember that my P's are here. I'm going to put my box over here for helium. S's are here. D's are here. F's are here. Remember to jump down one energy level. Oops. for the Ds. And let's do the shorthand electron configuration for phosphorus. So go up one level, one row, go all the way over, and you hit neon. So we're going to place neon in brackets. And now neon is my new starting point. So I need to finish off the rest of the electron configuration. So start back at the 3s. There are 2 boxes there, so 2 electrons. Go over, there are more boxes that need to be written down in that 3rd row. So 3rd row, 3rd energy level, p orbital, and 1, 2, 3. 3 electrons. And that's how you do the shorthand electron configuration for elements using your periodic table.